Hello all, welcome back to Engineering Economy course. In this lecture we will start chapter 10 from your book, in which we will learn the benefit-cost ratio method and how to use this method to evaluate projects. This is especially useful to evaluate public projects, and we will first learn some terminology and some differences related to these public projects, their differences from private projects. And then we will learn the benefit cost ratio method, and we will solve several examples and implement the benefit cost ratio method to evaluate project alternatives. So let's get started. So the learning objective in this chapter is to illustrate the use of the benefit cost ratio method to evaluate public projects. Okay, and as the name implies, in the benefit cost ratio methods, we will focus on the benefits of the project and the cost of the project, and we will calculate the ratio, the benefit to cost ratio, and we will use this ratio to make our final decision. The public projects are different than the private projects. There are several differences. So let's have a look at what are some of these differences. First of all, the public projects are usually much larger than private projects in terms of their monetary equivalent, in terms of the time and as such. They may have, the public projects may have multiple varied purposes, and these are usually conflict with each other. So you don't do a public project for a single objective, just to earn money, for example, but you do this, for example, to serve people, to have an economical, environmental friendly, a healthy, a sustainable system, and etc. So all of these are different purposes, and usually in order to satisfy or maximize one of these objectives, another one you need to sacrifice from another one. So that's the meaning of conflicting. Usually the project lives are very long. The capital source, the necessary financial amount to conduct this project, is satisfied usually by the taxpayers, the public, the people. Okay? The decisions that we come up at the end are usually politically influenced. Okay? And there are benefits of the project, and usually these benefits are non-monetary items, and they are difficult to measure. And also there may be some disbenefits in the similar way, which is difficult to quantify as monetary equivalent. So these are several differences of the public projects from the private ones. We can concentrate. This table actually summarizes the differences between public and private projects in terms of the purpose. In private projects, the purpose is to provide goods or services at a profit, maximize profit, or minimize cost. But in public projects, the purpose is to protect. It can be the protection of health, protect lives and property, provide services at no profit, and provide jobs, and etc. similar objectives. The sources of the capital in private projects, the source is the investors and lenders. But usually in public projects, the source is the public, the tax earnings, and it can also be private lenders. The method of financing the project in public projects, it's individual ownership, partnership, or corporations. But in public projects, the method of financing comes from direct payment of the taxes, the loans without any interest. As a government, you can have such loans, or loans with very low interest rates. It can be some self-liquidating bonds, indirect subsidies, guarantee of private loans. So as a government, you have many more options with no interest or very low interest. The multiple purposes in private projects, there may be still multiple projects, but it's at a moderate level. But multiple projects are very common in public projects. We will see examples of such multiple purposes. Project lifetime in private projects is usually relatively short, 5 to 10 years, but in public projects usually it is long, 20 to 60 years. And the relationship of suppliers of capital to project. Okay, who supplies the capital and what is their relation to the project? In public project, there's a direct relationship. I mean, the owner of the project supplies the capital. But in public project, it's indirect. The taxpayers supply the project, and the taxpayers supply the capital, and they don't own the project actually. So there is an indirect or no relationship. The nature of the benefits in private projects, the nature of the benefits can be quantified in monetary units, or it's relatively easy to equate the benefits to monetary terms. But in public, it is often non-monetary. There are often non-monetary benefits, and it's difficult to quantify, different to find the equivalent monetary terms. In terms of beneficiaries of the project, in private project, the beneficiaries are primarily entity undertaking the project. I mean, who is conducting this project? The company, the person, okay? But in public projects, usually the beneficiary is the general public, you, me, okay? In conflict of purposes, I mean, if you have multiple purposes, is there a conflict of these purposes? In private projects, there can be, but it's at a moderate level. But in public projects, it's quite common. We will see examples. Conflict of interest, again, in private projects, it's moderate. But in public projects, it's very common to have conflict of interest because there are different agencies, different groups within the public. They are affected by this project, and there is a conflict. Usually there is a conflict between them. Effects of politics in private projects is it's little or to moderate level, but in public projects it's very frequent. There may be different decision makers, and the decision makers may change from time to time. So there's a short-term tenure for the decision makers, and whenever a new decision maker is appointed, then the project can be changed or removed. There are pressure groups, and there are financial and residential restrictions, and etc. So the effects of politics is too much in public projects. And the measurement of efficiency is rate of return on capital for private projects, but in public projects, having such a measure of efficiency is very difficult. So no direct comparison with private projects. We cannot compare them. Okay, so this table summarizes the basic differences between public and privately owned projects. As a result of these differences, the engineering economy studies for publicly funded projects are very difficult. And also, even in public projects, the benefits must exceed the costs so that the project fund, the public fund can be justified. Especially, there are some public projects which are funded by foreign loans. This criterion is mostly used. But there are difficulties. So we say benefits and costs. We are not saying revenues, benefits. And how shall we define these benefits, and how shall we define these costs for public projects? It's very difficult. So for any project, we need to have a proper perspective. Remember the principles of engineering economy. We need to have a perspective. And for a publicly owned project, what is the perspective? Who is the owner of the project? Usually in public project, in governmental projects, the owners are the public, the people. Okay? So we should look from the perspective of the people. But the thing is, the people that lead, that own, that manage this project are different than the public. The public cannot manage the project. The electives or the administration does this project. Okay, so the owners and the project leaders are different. So the benefits, we say there are benefits of the project. How do we define benefits? Benefits are favorable consequences of the project to the public, which are the owners. And these benefits, sometimes they can be tangible and sometimes they can be intangible. Sometimes we can measure them in terms of monetary units. It's very easy, but sometimes quantifying those benefits is not easy. There are some unseen, unforeseen benefits and etc. So the benefits can be divided into these tangible and intangible categories. There are also disbenefits of the project. These benefits represents the negative consequences of a project to the public. Other than the costs, there may be some negative consequences, and these consequences may be related with not the whole public, but with a small group of within the public. Okay, but still we need to consider these benefits. And the costs represent the monetary disbursements required for the project. And these costs can also be tangible costs and intangible costs. And in order to conduct these benefit to cost ratio analysis, we need to somehow know all these benefits, disbenefits, and costs. So let's see, let's try to understand the concepts of benefits, costs, and disbenefits with this example. Assume that a new convention center and sports complex is proposed for a city. This is a public sector project, and if the project is approved, it will be financed through the issue of municipal bonds. So the city will have some bonds to collect money from people. The facility will be located in the city park near downtown. It's a wooded area. There is a bike path, a nature trail, and a pond inside this park. Because the city already owns the park, no purchase of land is necessary. So we need to list this project's benefits, costs, and disbenefits. Okay, we need to think about all these. So what are the benefits? If we establish this convention center and sports complex in this park, what do we obtain? So these are some of the benefits. Improvement of the image of downtown area of Gotham City. With such a sports complex and a convention center, the image will be improved. Potential to attract conferences and conventions to this city. And with these conferences and conventions, many people from other cities, foreigners, tourists will come to the city, and it will be an additional earning for the city. Potential to attract professional sports franchises to the city. Revenues from rental of the facility. You can rent the facility for different types of conferences and etc. and you will earn revenues. Increased revenues for downtown merchants of Gotham City because of this convention center. More people will be attracted to the downtown and the merchants will have increased revenue. And use of facility for civic events. These are the benefits. What about the costs? The cost, architectural design of the facility, construction of the facility, design and construction of the parking garage adjacent to the facility, operating and maintenance cost of the facility, insurance cost of the facility. These are the costs which can be measured in terms of monetary equivalent values. But there are certain disbenefits of this project also. We need to think about these as well. What are these disbenefits? Loss of use of a portion of the park. So currently there is a park there and a portion of this park will be allocated for this convention center and sports complex. And we will not be able to use that portion of the park. So the residents will not be able to use it. This will include the bike path, the nature trail, and the pond maybe. Okay. And also there may be a loss of wildlife habitat in the urban area. So you see, these are not costs. These are not measured in terms of monetary equivalents. They are disbenefits, and these disbenefits need not to be to the whole public, but maybe a group of the public, just like the residents in the downtown, in the closer area, or to the wildlife, to the environment. There are several public projects which can repay their own costs, and these projects are called self-liquidating projects. In these projects, it can be, for example, power supply, water supply, sewage disposal. There may be paid bridges and highways. In these projects, as the cost of these service, some money is collected. So this money, collected by the users, from the users, pay the costs of the projects. So these projects earn direct revenue, but this revenue is earned to repay their costs, in their construction costs or operating maintenance costs. But since they are governmental projects, public projects, they are not expected to earn profits, or they don't pay taxes. Okay? These are just for the purposes of paying the cost of the project. And these are called self-liquidating projects. As I said previously, usually public projects, governmental projects, have multiple purposes. Okay? Let's consider an example of constructing a dam on a river. Okay? So what are the different purposes, direct, indirect purposes of such a project? What can be? It can be electricity generation by allowing water to pass through turbines. Then we can generate electricity. We can use the dam for irrigation of the land. We can use the reservoir of the dam for flood control. We can satisfy the drinking water requirement of the area close by cities from this dam. And also we may have recreational facilities around the dam for fishing, for kayaking, okay, for different purposes. These can be different purposes of constructing a dam. Several, or usually governmental projects have such multiple purposes. And For example, consider the electricity generation. We generate electricity from this dam, and we need to assign a cost for the electricity. Okay, then what will be the selling price of this electricity generated by this dam? In order to do that, we need to know the cost. But what cost is it? Is it the cost of constructing and operating and maintenance of the dam? Because as we said, there are multiple purposes for constructing this dam. Water irrigation system is another purpose. And for irrigation, again, we will collect money from the farmers for the water they are using. What will be the selling price of the water? So in order to know the selling price, again, we need to know the cost. But what cost is it? So we need to somehow allocate the total cost into these purposes. So what will be the selling price of the electricity depends on the cost allocated for that purpose. But how to allocate this? It is very difficult to allocate the costs to these different purposes. And also, some of these purposes are in conflict and they are politically sensitive. So think about these two purposes. Generating electricity was one of the purposes, and another purpose was flood control. In order to control the flood, your reservoir area should be empty so that if there is a huge amount of flood, you can stop it in your empty reservoir. But in order to generate electricity, you need your reservoir to be higher than a certain level so that you can generate electricity. And also for your recreational areas, again, the water level should be at a constant so that these recreational facilities can work. But for flood control, you need an empty reservoir, and for electricity generation, you need a certain amount of water, and these purposes conflict with each other. Okay, so usually in public projects where there are such multiple purposes, they conflict with each other. And because of these, the cost allocation in such multi-purpose public sector projects tend to be arbitrary. I mean, the electricity price, the price of the water irrigation system, the price of the drinking water. So since you cannot allocate the cost to these purposes, there is no way to allocate it, then usually the costs are allocated arbitrarily. So there are certain differences, difficulties inherent in engineering economy studies in the public sector. So we are going to list several of these difficulties here. First of all, in public projects, usually the measure of effectiveness is not the profit. Usually governmental projects are non-profit. So you cannot maximize, you cannot select the project which maximizes your profit, okay, in a governmental project or a public project. Many benefits, you cannot quantify them, you cannot find their monetary effect. Okay, it is difficult to quantify. There is little or no connection between the project itself and the owners. And in a public sector, public project, the owners is the people, the public. And usually there is little or no connection between them. Usually in public projects, instead of long-term benefits, short-term benefits are considered because of political reasons, because you know the politicians have a specific or certain amount of time to serve for 5 years. After that, they need to be re-elected, and usually they don't consider the period after these elections. They consider only until the time that they are elected. If they are re-elected, they may continue with the project, but if they cannot be elected, the newly elected ones may have other idea, different idea. Therefore, the short-term considerations or benefits are considered. Usually public projects are more subject to legal restrictions than private projects. Okay, this is another difficulty in evaluating public projects. There is strong political influence since the public funds are used, and these political influence can come from pressure groups, different groups inside the public. Many people, many groups will ask for different things for the project, and therefore it is very difficult to make the final decision. To obtain the capital for a public project, it is very difficult. There are different procedures, different methods. So you cannot just say that I am getting this money from the tax and I will use this for this. There are different committees, different systems in different countries, and usually it is difficult to obtain this capital. And the interest rate for making the engineering economy analysis for discounting the benefits and costs is usually politically sensitive, and it's difficult to identify this interest rate in public projects. So let's talk a little bit more on this interest rate. Choosing an interest rate for a public project is not that easy. It's very difficult, and we need to have different considerations. So the main considerations, one consideration is you can consider the rate on borrowed capital as the interest rate that you use in your engineering economic analysis study. So if you are borrowing this capital from a source, then you can use the rate of this borrowed capital for your study analysis. Another thing that you can use as the interest rate is to consider the opportunity cost of this capital to the governmental agency. So assume the governmental agency is considering to perform this project, and there are opportunity costs. There's an opportunity cost related to this project. So if you don't do this project, what is the next best alternative? So by considering this next best alternative, you can identify the interest rate. Or instead of the opportunity cost to the governmental agency, the opportunity cost of this capital to the taxpayer can also be considered. So as a taxpayer, if we don't perform this project, what is the next best alternative for the taxpayers? Okay, we can consider this to identify the interest rate. The thing is, if the money is borrowed specifically for this project, so as a governmental agency, you are borrowing this money, and you are borrowing this money for this project, for not a general purpose, for not something else, then the interest rate of this borrowed capital is appropriate to use as the interest rate for the engineering economic analysis studies. Okay. There is another theory, another view on establishing these interest rates for public projects. It says that the interest rate should be the market-determined risk-free rate for private investments. So in private investments, until now, we were using those investments. We were considering the market rate. So what is the next best alternative? How you can earn interest? But on top of that, we were adding a risk. But in governmental projects, we exclude this risk, only the rate itself. Okay, so as a bottom line, we can say that there is no simple formula, and it's an important policy decision at the discretion of the governmental agency. So there is no simple formula to obtain the interest rate for a public project. So when we consider governmental agencies, regulated monopolies, so there are some companies, they are regulated, they are not governmental agencies, but they are monopolies. They are the only ones that need to provide this service or establish such a company. And there are private enterprises. And if we look at the interest rates of these three groups, I mean, what interest rate they can borrow money and use in their analysis, we see that for private enterprises, the interest rate is the highest, and for governmental agencies, the interest rates are the lowest, and regulated monopolies are in between these two. Okay, now after this introduction, talking about the differences and the basic terminology related to public projects, we can start talking about the benefit-cost ratio method. Simply, benefit-cost ratio is the ratio of the benefits to the costs. Okay, that's it. Ratio of benefits to the costs. But the thing is, of course, we will consider the time value of money. Therefore, it is not just the ratio of benefits to the cost, but it is the discounted benefits, the ratio of discounted benefits to the discounted costs. When we evaluate a project using the benefit-cost ratio method, shortly we will say BC ratio method, the result, the final decision, will be identical with the methods that we previously learned in the present worth method, annual worth method, future worth method, IRR or ERR. So these were the methods that we already learned to evaluate project alternatives. And the BC ratio is another method. And the recommendation after the BC ratio method, if we use these methods appropriately, we will obtain the same decision. And this BC ratio simply is the ratio of the equivalent worth of benefits to the equivalent worth of costs. And when we say equivalent worth, it can be present worth, future worth, or annual worth. There are different formulations of the BC ratio, but in this course we will learn simply two versions of it, the conventional BC ratio and the modified BC ratio. In conventional BC ratio, simply we will find the equivalent worth. In this example, we are calculating the present worth, but it can be annual worth or future worth as well. So the present worth of the benefits of the project divided by the present worth of the total cost of the proposed project. Okay, this is the BC ratio. In conventional method, for the benefits, okay, at the top we have these benefits, and in the denominator, this is the initial investment cost. So consider such a project, okay. We have this initial investment, we have this market value or salvage value at the end. At each year, we have operating and maintenance costs, and again, we have these benefits, okay? It can be revenues plus other intangible benefits and etc. So whenever we are talking a project, we are considering this kind of a cash flow. So at the top, we have these benefits. At the denominator, we have this investment cost. As you can see, the market value, the present worth of the market value is subtracted from here. although it seems to be a benefit in the conventional method, we used it as in the denominator and the present worth of the operating and maintenance costs. In the modified version of this, what we do is in the numerator we have the present worth of the benefits like the previous one, but this time we are subtracting the operating and maintenance present worth of the operating and maintenance cost. Simply, you can assume that you are just finding the net value. B minus O and M is the net annual value. And in the denominator, we have the investment minus the present worth of the market value. Okay, what happened? We just moved this operating and maintenance cost to the numerator as a negative, as a minus. Okay. So these are the two formulations, conventional and modified BC ratios with present worth. If we use this with annual worth, again the idea is the same. Annual worth of the benefits divided by annual worth of the costs. In the conventional one, we have annual worth of benefits divided by, look, this is CR now, capital recovery. What is capital recovery? Remember, we find the annual worth of this present initial investment by multiplying this factor, A given P, I, and N, and subtracting from here the market value, A given F, I, and N. Okay, so this is the capital recovery. So here we write capital recovery plus the operating maintenance costs. In the modified version, we just move this operating maintenance cost to the numerator as a negative, as a minus one. Okay, and this is the conventional and modified BC ratio with the annual worth. Exactly the same with the present worth, nothing different. And you can do the future worth in a similar way, but the present worth and the annual worth are the most common ones than when we compare with the future worth. So with this example, let's try to understand this method better. So it says that in this example, the city of Columbia is considering extending the runways of its municipal airport so that commercial jets can use the facility. Okay, extending the runways is the project. The land necessary for the runway extension is currently a farmland, and we can purchase it this much. Okay, this is the cost of the land. Construction costs for the runway extension are projected to be, this is the construction cost. Additional annual maintenance costs for the extension are estimated to be this much. These are the additional costs for maintenance. And then it says that if the runways are extended, a small terminal will be constructed. This is terminal building cost. The annual operating and maintenance costs for the terminal are this much. Finally, the projected increase in flights will require the addition of 2 air traffic controllers at an annual cost of this much. Okay, these are all the costs associated with extending the runways. Some of them are capital costs, some of them are annual operating and maintenance costs. And the annual benefits are listed like this. This much rental receipts for airlines, airport tax charged to passengers, convenience benefits for residents, and additional tourism dollars. These are the benefits and they are quantified. It says that apply the BC ratio method with a study period of 20 years and a MAR of 10% per year to determine whether the runways should be extended or not. Okay, so we will solve the same example using the modified BC ratio method and the conventional BC ratio method. We will use both of them. And the thing is, by this example, we will show that actually these two methods will provide exactly the same decision. We are not saying that, I'm not saying that the BC ratio will be the same. They will be different. but the final decision will be the same. So whichever method you use, conventional or modified, your final decision will be the same. Okay, let's solve the example. Again, what we will do, we will find the ratio of benefits to the costs. So in conventional BC method, what we do, remember, present word, let's use present word. You can use annual word also. So we will solve present and annual. Solve the same example with both of these methods. So initially, find the present word, divide it by the initial investment, present word of the market value subtracted, plus the annual operating and maintenance cost. This present worth of the benefits are listed in the table. Just sum up those benefits and you will obtain this. Okay, and so these are annual values and we need to find its present worth. This is the MAR and this is the study period. This is the initial investment. The construction plus farmland plus construction of the terminal building. And this is the annual maintenance cost and find its present worth. Okay, so this is the conventional BC using the present word. And when you do this, you see the ratio is this much. So if you use conventional BC with annual word, okay, so what we do, we find the annual word of the benefits, which is this much already. We find the capital recovery. So in order to find the capital recovery, I need to find the annual worth of this capital recovery and the operating maintenance costs. Okay, so there is no market value associated with this one at the end of 20 years. It's 0. And as you can see, the BC ratio is 1.448, exactly the same. Okay, so if you use present word, conventional present word or annual word, the ratio will be the same. If this is not present word or annual word, but the future word, again you will find the same ratio. Okay, but I'm talking about if you are using conventional. If you use modified BC version problem with present word, you see what we did. We use this operating and maintenance cost as a negative in the numerator now. Okay, and in denominator we have this, and you see the BC ratio is now different. But if you use modified BC ratio instead of present word, if you use annual word, you will obtain the same value as you can see. Okay, and if you use modified BC with future word, again you will obtain the same. So it means that with conventional BC method, if you use present word, annual word, future word, you will obtain the same ratio. If you use conventional and use present, annual, and future, the ratio will be the same. They will be identical. And look, the conventional and modified ratios are different, but the final result, the magnitude is not important here. We need to compare this with 1. If the ratio is greater than 1, it means that the benefits are more than the cost. Therefore, we accept the project. If this is less than 1, then the benefits are less than the cost and we reject the project. So the comparison in BC ratio is with 1. We compare this ratio with 1. If it is greater, we accept the project, otherwise we reject. Although their values between conventional and modified are different, the final decision is the same and it will be the same. In some cases, we also include these benefits into the formula. So in the previous example, we have the benefits and costs, but no associated disbenefits. But also we can include these disbenefits, and we can include these disbenefits in different ways. For example, we can include it as a negative in the numerator, okay, subtract these disbenefits from the benefits. So we have this annual word if we use the annual word. So this is the conventional method. Okay. So in the conventional method, we subtracted it from this benefit. Again, in the conventional method, instead of subtracting it from the benefits in the numerator, we can add it to the denominator as a cost. Assume this benefit as a cost and add it to the denominator. Okay, and the thing is, whichever alternative you do, the final decision will not be changed. Again, the BC ratio, the value may be changed. The final decision will be the same, whether you will accept in both versions or you will reject in both versions. So if you like, so we used here conventional method. You can do the same thing with the modified method. You can either subtract this from the numerator or add it to the denominator in the modified version, and again you will obtain same whichever method you do. So I'm not saying this, be careful. If you don't consider this benefit, if you just consider the rest, so this version and considering these benefits may give different results, different decisions. I'm not saying that they are equivalent, okay? When I say they are equivalent, I'm saying that whether you subtract these benefits from the numerator or add these benefits to the denominator, you will obtain the same result. But in both cases, you need to consider these benefits. So let's consider this example to understand these benefits. Okay, so this is the same example of extending the runway in the airports. And now assume that due to the increase in the noise level because of the jet traffic, the people, the homeowners living around this airport will have some problems. And this benefit due to this noise pollution is estimated to be $100,000. Okay, one thing is, how can we estimate the cost of this increased noise? It's very difficult, okay? It's not easy. It's not something that you can measure. But in this example, assume that we measured it, we estimated it, and we are going to use this as this benefit, and we will use the conventional BC method, it asks here, with equivalent word to determine how these benefits affect the recommendation. So what do? We can assume these benefits and subtract it from the benefits in the numerator. So simply we subtract this 100,000 from these benefits, and we use the conventional BC method, and you see that the result is greater than 1. The decision is still to extend the runways. If we assume that this benefits as a cost and add it to the denominator, okay, and we do the calculation, we see the BC ratio is this. It is different than the previous one. But the thing is, the final decision is the same, and it will be the same. Okay, with this example, we see that the final decision does not change even if we apply these benefits as a negative in the numerator or as a positive, as a cost in the denominator. So sometimes we need to classify some certain cash flows as being whether they are benefits or they are reduced costs while calculating this BC ratio. Okay, how to classify this? And the previous example actually showed us that the numerical value of the ratio may change, but there is no impact on project acceptability regardless of how we handle these cash flows. Okay, the ratio, the value of the ratio may change, but the final decision, the go, no-go decision, will not be affected if you consider it as an added benefit or a reduced cost. Let's consider another example to see this, to identify this. So a project is being considered by the Department of Transportation to replace an aging bridge across a river on a state highway. The existing two-lane bridge is expensive to maintain and creates traffic bottleneck because the state highway is 4 lanes wide on either side of the bridge. The new bridge can be constructed. This is the construction cost. An estimated annual maintenance cost is 10,000. The existing bridge has annual maintenance cost. This is for the existing bridge. The annual benefit of new 4-lane bridge to motorists due to the removal of the traffic bottleneck has been estimated to be 25,000. So it says conduct BC analysis using MAR of 8% and the study period of 25 years. So in this example, you see this is the annual maintenance cost for the existing bridge. And when we replace this bridge, what will happen to this annual maintenance cost? It will be removed, right? So we can assume that this is an increased benefit, added benefit. Or we can consider that our total cost will be reduced this much. So it is a reduced cost, not an increased benefit. So actually there may be two alternatives for this. Considering this as an added benefit in the numerator or considering this as a reduced cost in the denominator. Which one is more suitable and how critical it is for our decision? So again, we will use the BC ratio method. We will use the conventional BC ratio method and we will use with the annual worth method. So this is the annual worth of the benefits, okay, for the new bridge. This is the capital investment and we find its annual worth. And you see this was the old bridge operating maintenance cost and we are subtracting it. We deal it as a reduced cost in the denominator. And this 10,000 is the annual maintenance cost of the new bridge. It is a cost, so we are adding it. So there is this parenthesis. If you open this parenthesis, this is negative and this will be positive in the denominator. Okay, so we deal this part, this annual maintenance cost, as a reduced cost. And if you do this, the BC ratio is this much, and since it is greater than 1, the final decision is to construct the bridge. If we assume instead this 18,500 as an increase in our benefits, so we can write it in the numerator, okay, 25,000 plus 18,500 minus 10,000. So we are considering this total annual maintenance cost, the change in the annual maintenance cost, as an increased benefit in the numerator. And the only cost is the capital cost, and we find its annual worth. And as you can see, the numeric value is different than the previous one. But the final decision, both of them are greater than 1, and we accept this project. So you can use any one of these versions and you will obtain exactly the same answer. So this is the end of this topic. We considered the benefit-cost ratio method, which is a useful tool for especially public projects, but also for private projects. You can use this benefit-cost ratio method.